This video is solutions to assignment 2A on sequences and series. So let's start by looking at the first question. Express f of x is equal to 3x plus 5 over x plus 1, x plus 2, x plus 3 in partial fractions. So this is something that should be quite familiar to us. F of x is equal to 3x plus 5 all over x plus 1, x plus 2, x plus 3. So if this is in partial fractions, well, we know then this is identical to some coefficient a over x plus 1 plus some coefficient b over x plus 2 plus some coefficient c over x plus 3. And because these are identical, I can cross multiply both sides, doing this the long way. So if I multiply everything by x plus 1, x plus 2, x plus 3, left hand side these would cancel out and I'd be left with 3x plus 5. And right hand side, well, here I would get a times x plus 2, x plus 3, plus b times x plus 1, x plus 3, plus c times x plus 1, x plus 2. Now the neat thing about this fact that this is an identity and not an equality means that I can substitute in whatever value for x I like. So in this case I'm going to say x equals to negative 1. And if that's the case, I get negative 3 plus 5, I'd get 2 equals to a times 1 times 2, so 2a, plus 0b plus 0c. So that means that a equals to 1. I'm now going to substitute in x equals to negative 2. Here I'll get negative 6 plus 5, so I'll get negative 1. And that will be 0 plus minus 1 times b, so minus b, which also gives us that b is equal to 1, and then I get x. I'm going to substitute in x equals to negative 3 to cancel out these two guys, and so I get negative 9 plus 5, which is negative 4, and that's going to be 0 plus 0 plus, if I substitute in here I get negative 2 times negative 1, so I get 2c, and that gives me c is equal to negative 2. So therefore, f of x is equal to what? It's equal to 1 over x plus 1 plus 1 over x plus 2 take away 2 over x plus 3. What's the next part? The next part says that given x is sufficiently small for x cubed and higher powers of x to be neglected, show that f of x is approximately equal to 5 over 6, take 37 over 36x, plus 227 over 216x squared, and state the range of values for x for which this expansion will be valid. So, let's start this on a new page. I know now that, come on, there we go, f of x equals to 1 over x plus 1 plus 1 over x plus 2 take away 2 over x plus 3. Or, in other words, I can write this as x plus 1 to the negative 1 plus x plus 2 to the negative 1 take away 2 x plus 3 to the negative 1. Now ideally I want to do my binomial expansion on these terms, but I can't just yet, because to do binomial expansion I need it in the form 1 plus x. So the first one, that's no trouble, but for the second one, what do I need to do? I need to bring out a factor of 2. So in here I'll have 1 plus x over 2 to the negative 1, and then a 2 to the negative 1 also comes out the front, so I have a half out here. Similarly, here I'm going to have 1 plus x over 3 to the negative 1, and so I'm going to get a 1 over 3 appearing out the front. So now I can do my binomial expansion on this, and if I just do them separately, oh no, I don't have to do them separately, so therefore f of x is equal to, if I expand this first one, what do I get? I'm always going to get 1 to start with, plus n times x plus n minus 1. So minus 1 will be minus 2 over 2 factorial x squared. And then I don't have to pay any attention to higher powers because I was told they could be neglected. It's important to leave the dot 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 in there though, or if you don't, to change this to an approximately equals. Because the only way it's equal is if we still represent that there is more there that we're just chopping off. So then this is plus a half times 1 plus n times x. So in this case our x is actually x over 2 plus n minus 1 over x squared over 2 factorial times x squared plus dot dot dot. And then the final one is not plus now, it's minus 2/3 1 as always minus plus n times x, so here our x is x over 3 plus n minus 1 over 2 factorial x squared. And there is more, but again I don't need to pay attention to it. Okay, so if I simplify this, what do I get? Well, I would then get 1 minus x plus x squared minus dot 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 plus, first term will become a half, this term will be minus x over 2 times a half, so minus x over 4. This will be plus x squared over 4 times a half, so plus x squared over 8. And that carries on. And the last one will be minus, now we've just got to be a little bit careful because we've got a minus sign, but it'll be minus 2/3 and then minus 2x over 9, and then this will be plus let's cancel, so we get x squared, so 2x squared over 3 squared times 3, so over 27. Yeah. Right. Now, ideally what we should do is we should then tally them up so that we get, this is equal to, approximately equal to this time. This will be 1 plus a half minus 2/3 plus minus x minus x over 4 plus 2x over 9 plus x squared plus x squared over 8 minus 2x squared over 27. And so that is equal to, and you notice this was approximately equal because this is approximately equal to this, but now it's equal because this is equal to this line above it, and that will actually be equal to 5 over 6 minus 37 over 36x plus 227 over 216 x squared, which is what we wanted to show. Now the last thing it wants us to do is to talk about when this expansion is valid for. Well, when I expand this one's valid when mod x is less than 1. This one's valid when mod x over 2 is less than 1. And this one's valid when mod x over 3 is less than 1. So mod x less than 1, what does that mean? That means minus 1 less than x less than 1. Mod x over 2 less than 1 means what? Well, the 2 would come up, that's mod x less than 2, so negative 2 is less than x is less than 2, and then mod x over 3 less than 1 would give us minus 3 less than x less than 3. Now the important thing is, for the f of x expansion to be valid, we need all three of these to be valid. and that only happens, it only happens for this one here. So this is our condition. We need mod x to be less than 1 or x to be between -1 and 1. And with that we are finished.